Good evening, everyone. Welcome to this evening's PyLadies. We have a few talks on this evening and just a few announcements before we start. Just to introduce myself, I'm Vicky. If you don't know me already, I'm one of the co-organizers of PyLadies Dublin. Uh, so, uh, I want to say thank you to the speakers and to all of you who are joining us this evening, and to our community sponsors. First, to Manning Publications, who are, as you can see here, they're offering 3 ebooks for us to raffle off this evening. So after the talks, I'm going to pull the names from the live chat that we have there on YouTube, live chat on YouTube. And we're just gonna pick names from I think I'm a name picker. Okay, I'm using Ninja name picker or something, and then I'll contact you, or you can contact me on how to claim those books. And there's also for those who want to get some books from Manning, they've offered a 35% discount on their books with the code MTPython PyLadies 20. It's highlighted there. It's valid for 4 months, and there's a link that you can visit to use the code. And also, thank you to Dublin Maker as well for community sponsor. I'm using their Zoom right now for the meetups. So we're gonna have 3 talks this evening. We're gonna have Nabanita, who will be giving a talk on an introduction to fraud detection using machine learning. It's gonna be a 15-minute talk, and it's followed by me. I'm gonna be demoing my on-air sign with CircuitPython and Pi0, and Lais will be giving a talk from Jupyter to production code and easy conversion path. So sort of kind of the agenda for this evening, and see, we're sort of on time. I think we are. We're ahead of time actually. And some announcements. There's yeah, so for those who don't know already, EuroPython, all their 130 edited videos are now all available. So head over to europython.tv. I'm still plugging this. PyLadies Dublin is on Dev2, so anyone here who is on Dev2, which is a nice platform for blogging your tech articles or put up your podcasts or your videos and stuff. If you're there, connect with us, and if you're not, go check it out. It's just really nice. The post blogs on all the things that you find cool. So here are just a few people. That's me. I'm YK, and you have Chuck, who does a lot of who's been doing a lot of Python community stuff, and then one of our this evening's talkers, she's also there as well. You can find her in Dev. So we're gonna have one more meetup next month, and that's it till 2021. So we are looking for speakers for 2020 onwards. So if you're interested, you can submit via this type form. You can find all this information on this CryptPad, which is linked off our this evening's meetup page. So head over there and click on it, and you'll see all these announcements. And as I said, next month is our last PyLadies Dublin meetup of the year. It's going to be on Tuesday, November 17th, and we're going to have 2 talks. One by Christina on deep tree, automatic deep lineage tree analysis via single cell tracking software, and Jaime Belta talking about software architecture for proctoring tool. And then we'll also have 3 books for Manning next month as well, up for grabs, and that's and then yeah, that's the main PyLadies event next month. And then there's Python Ireland. Their next meetup in November is Wednesday, November 11th. So check it out on python.ie or on Meetup. I don't have a list of all the upcoming events that are happening this month, so but I do have a link to my live blog posts of all the Irish hosted tech events, so you can check that out via this link. So I think we're totally ahead of time. Yeah, so that's great. A bit of breathing space for our speakers. So first, I would like to have Nabanita to talk about an introduction to fraud detection. So, up over. So, hi Nabanita, you're on Zoom now. So, whenever you're ready, you can share your slides, and I'll leave the floor to you.
All right. Can you see my screen? Is the presentation visible? All right.
Give me a second.
Yeah.
Give me a second.
Yeah, I can.
Can people see the presentation?
I can see the screen,
There
yes.
you go. Yeah, I'm just fixing it up because it looked weird. So yeah, you're good to go.
All right. Thank you everyone for joining. I'm going to give you a very high level presentation on how fraud detection is being done in the industry using machine learning and a little bit beyond that. So introducing myself, I am Nabanita Roy, and I am working as a data scientist at Fiserv. I've completed my master's from Trinity College Dublin 2 years back. And then I've been in Ireland for the last 2 years, and I'm really enjoying this. So starting this talk with a little bit of knowledge on what a credit card or online fraud is. It's only when you, as a customer, you have purchased anything online, or when the card is not present with you physically. So with the huge advent of all the e-commerce businesses where you use a lot of online purchases, especially in the lockdown, you would see a lot of we've seen so many online transactions have been happening all over the world. So the fraud rates have also increased over the years with loads of data, loads of online users, advent of social media and everything. So as days have passed, detecting fraud has been it's really important to us. So traditionally, machine learning was not used. It was mostly around statistical analysis, using rules engines and manual reviews, which would basically be really tedious. Now, just to say how frauds affect us, or who frauds affect, it affects the customers, number one, because your account is being charged every time there's a fraudulent transaction. Not to talk about the little hard sacks that you'd get if you see some transactions that you haven't made for like 50 euros or 100 euros, or even more than that. The second one is the merchants. Merchants is the shop from where you have purchased something, without your card being physically present there. So these merchants are the worst hit, basically, because they are the ones who are supposed to refund your money, and they're also liable to pay some charges because a fraudulent transaction has happened from their site. And then the payment service provider. So due to the ever changing laws and protection rules, so the payment service providers, they were not initially liable for paying for these damages, but now they are, in Europe at least. So frauds affect all these three pillars of the fintech industry, for the fintech landscape. So it's very essential to detect frauds. Now, traditionally, like I was talking, traditionally fraud detection would be around, you would do some statistical analysis, you could use some clustering algorithms and see what are the typical patterns in which frauds happen. Now, fraud is basically detecting anomalies. Now, as we have become smarter using statistical analysis, and we have built algorithms to detect anomalies, the fraudsters have also become really smart. So now what they're doing is, when initially they would be in a hurry of making these fraudulent transactions, they would take like 1,000 euros of transactions at one go. What they are doing now, they're just making, random 20, 23, 50 euro transactions, because of which they are easily meddling into the genuine crowd. It's the separability between the fraudsters and the genuine transactions or the genuine customers have become increasingly difficult. And then traditional fraud detection methods would see, because there are so many rules to look out, and you don't know which rule it could easily, block a genuine customer for any exceptional cases, right? So we've seen, like, in traditional cases, there are high number of false positives, and because of higher number of false positives, you get many more manual reviews, because if you have false positive, that means you have blocked a genuine customer, and as a bank, you wouldn't want that to happen. That means you have upset a genuine customer, and that person would be reluctant to continue their relationship with this bank. So to have a separate layer of protection, they have, manual reviews on top of the rules engine. So that manual reviews, manual effort, they always consume time. They always consume a lot of costs. So these are a few drawbacks of what traditional fraud detection methods could have, as well as there are scalability issues. Now that, as data is expanding, it's been with ever expanding data, so you have scalability issues coming in the present times. Now, why machine learning for fraud detection? Machine learning is basically automatically detecting these different anomalies by separating the features in the incoming transactions, right? So they're very fast and also accurate because they learn from the previous histories. Now imagine if you have a fraud analyst looking through all the entire history of the data, and then it's just very tedious, and probably it's impossible, but a machine learning algorithm is basically doing it in a faster and accurate way. And also it's efficient, because for a fraud analyst to check a particular transaction, if it's genuine or fraud, it'll take some amount of time, even if it's as much as 5 minutes. It's long, because the present day architecture, they make this happen in per second. So that's how efficient machine learning architectures are in fraud detection. And then, of course, scalability, because machine learning alone cannot stand in the current landscape. It also needs cloud technologies to handle the exponentially increasing data. So of course, machine learning in fraud detection with machine learning is highly scalable. So that's one of the advantages of using machine learning for detecting fraud. And then a typical data science life cycle, fraud detection also goes through the same steps of collecting data. So before collecting data, you have business understanding, which is very important, and we'll go through these steps individually. Then you prepare the data, get the features, look at the data, do some exploratory analysis, then you model, evaluate, and deploy, depending on the fact that if the results are satisfactory or not. So coming to business problem understanding. So in fraud detection, there are typically two cases. So do you want to upset genuine customers more, or do you want to catch frauds more? There are two things that you need to balance, because if you have more false positives, then you are going to upset genuine customers. And if you've got false negatives, that means you're allowing more and more frauds, but then you are saving your genuine customers. So that's the business problem. Now it differs case to case, client to client basis, which industry does that client belongs to, and if that client would be able to handle upsetting their genuine customers, or is it important for them to save the frauds. So also depends on the costs, how much each client is ready to bear for every losing genuine customer or every caught frauds or every fraud that they let go. And then that's about the business problem, and then preparing the data. So you'd see most of the financial banks or financial institutions, they would already have huge data. So it's really easy for them to gather a lot of data. What comes along is the technical aspects, as well as, probably their system was built in the olden days, so they'd have traditional data handling mechanisms. So so right now, if they're placing machine learning, they would also have to have that kind of data structures that are used in machine learning. Now, for preparing the data, you'd also need data labeling. And somehow in fraud detection, of course, data labeling is a big part, because all the time you wouldn't know which one is a confirmed fraud, something that you already know, you're 100% sure that that is a fraud. Many times you would be a bit you'd be skeptical if that is a fraud or if it's a genuine one. So that is one of the problems. But problems. And then the other problem is that the data is highly imbalanced. So in a machine learning fraud detection typical project, you'd expect to have at least 1% or 2% of data which is fraud, in order to at least in order to oversample or use undersampling techniques. So it is a challenge from the beginning. So that's about the preparing the data. So handling the imbalanced data, we already have loads of techniques. You could use mode, you could use any other oversampling techniques for handling imbalanced data. So that's about preparing the data. Then you have feature engineering. So feature engineering is the most interesting part of a fraud detect use case. You have to identify the customer. You'd see there would be emerging patterns in the types of devices that the person has used. So you could have a person using different phones for the same purchase, which is suspicious, right? And then you'd have email addresses. So there would be some email addresses which are not of a right domain. There would be blocked domains as well that you wouldn't want to let these kind of customers with that particular email addresses to be blocked. And then you'd have multiple usage of phone numbers, problematic from phone numbers. So as you explore the data or you do clustering analysis, you could also do network analysis that I'll talk about in the fifth point. All these things, they are used to profile a particular customer, and we always get like interesting patterns emerging from this, from analyzing a customer's profile. The second thing is location analysis, which is also very interesting. So you could be at your home, and you couldn't really, if you had one transaction today near your home, you cannot be tomorrow somewhere else, and which is say an international transaction. And then again at night you are at home and you're creating that, say, another transaction somewhere near your home. That sounds suspicious, because that's an anomaly that comes with an international transaction in between. So location analysis is really gets really interesting, and there are different ways of doing it. So there would be typically some thresholds to how much distance is allowed in between a home location and some adjacent locations in which you could make successful transactions without your card getting blocked. And then purchase history. So in finance, there's abundance of data. So getting a purchase history is not a problem. We would take an algorithm would typically check how many transactions have a person done in the last 24 hours, maybe in the last 3 days or over a month or over a quarter. So yeah, there's purchase history and then behavioral analysis. So that goes a bit of beyond machine learning. So sometimes you would check how long that person has been on that particular website before he or she has checked out. So if it's, say, like some really milliseconds, that is not possible, or because you have to manually enter and select stuff. So a considerable amount of time that is spent is a part of behavioral analysis. And the last one is also is network or association analysis. If you see fraudsters, they typically work in a network. They are like a workforce or like a team, and they support each other. So you'd find them always being together. They share same phone number, they would share same email addresses, they would share their location addresses. So evolving, if you get to a point where you could link these customers based on their profile elements, then you could really get a whole picture of a network that could emerge, and if you could potentially spot frauds from there. So if you could if you could engineer these kind of features, it would be really beneficial for your machine learning model. And I think if you look at 3 or 4 years back, that was a limitation for a machine learning algorithm, because a machine learning algorithm would not intuitively get hold of networks. But now there are techniques in which organizations are including network or association analysis in their machine learning landscape as well. So that's about feature engineering. And then talking about training a machine learning model. So that would mostly be a classification model. We could look at a fraud a detection project as a binary classification problem statement, in which you don't want to classify 0 or 1 typically. You would rather want to resort to get a score. So that score determines what is the probability of a transaction of being genuine or a fraudulent one. So a higher score would say that, okay, that could be fraud, so decline it. Then a score somewhere in the middle region, say if you're scoring from 1 to 10, so 7 to 10 is absolute fraud. So if it's from between 5 to 7, it would be, say, you have to review it, because the machine learning algorithm is not really towards the high end of that probability or the lower end of that probability scoring formula. So a manual review is necessary. So that's where you get the third classification category in this binary classification problem. So that's mainly like a separate layer of protection on what you're predicting and how you are dealing with a business problem. So training a machine learning model would also include, say, what algorithm you would like to choose. So the industry winner, or say global machine learning model winner, would be a random forest in terms of explainability as well. Whereas neural networks are gaining the speed of replacing these traditional machine learning algorithms. But the problem with explainability always lies with neural networks. So I think most of the times, most of the industries, they have random forests, but they would also not just have one machine learning algorithm. They would have multiple layers of machine learning algorithms and then ensembling their outputs together to get a fraud score. So that's about training and machine learning model. And then how these fraud scores are deciphered. So this distinction between what should be approved, what should be reviewed, and what should be declined, that heavily depends on a threshold score. So if you see this, if you're familiar with how we assess a binary classification problem, you'd see this is a confusion matrix in which you are trying to separate how many of them predicted are correct, how many of them of the predicted are wrong. And so the threshold determines the amount, the percentage that should be allowed on top of what the business allows you to. So normally you'd have two different thresholds. I've just drawn a single line to make it more simple. So how much false positives you'd want to allow, that would shift the threshold from in between that whole probability range of your fraud score. And you'd have an approved threshold, you'd have a review threshold, and then anything above that, the approved threshold would be approved. Anything in between the approve and decline would be reviewed. Anything beyond the decline threshold would be declined. So that's how these goes. And then, yes, we are dealing with machine learning, and the world is adopting machine learning in all their use cases. But there are a few cons that the fintech landscape has in terms of fraud detection. So the number one is cold start. So if you do not have enough data, now big banks and ones that who had stored all their data properly in their databases, they wouldn't have to worry about cold start, because they would eventually have historical, millions of transactions every month to prep their data, to prep their machine learning use case. But imagine for smaller organizations, that would be a difficult place to start. And then the second one is explainability, which is always a challenge in machine learning. It's just the talk of the town everywhere, and in most typically businesses would use visualizations and help of fraud analysts and case by case basis to explain what has happened, what hasn't. But it gets really difficult if the machine learning models goes towards neural nets and stuff. So yeah, that's about all that I wanted to discuss today as a part of my introduction to machine learning in fraud detection. And thank you for listening to me, and please let me know if you have any questions.
Can you hear me there?
Yeah.
So let me put this to standard. Thanks for your talk. We do have a few questions, but I think we're I don't think you have a minute to answer two questions. So what I'll do is we'll see if there's any time at the end after the raffle for questions. If not, you can submit we can put the answer up on the CryptPad where I did the announcements slides like that.
Sure.
So, and I'll send it on to people
Thank you.
who are RSVP'd and meet up as well. So I think time is a bit tight. So yeah, you got a minute to spare, but I don't know if there's enough time to answer. So what I'll do now is can you unshare your screen, please?
Sure.
Yeah. Cool. So I will actually I'm actually be talking next. So this is it'll be about my on-air sign with CircuitPython. A sec till I presentation. So hopefully that you can see it now. So yes, my on-air sign. So who am I? So again, I mentioned it earlier. My name is Vicky. I run tech events. Code a lot less than I want to nowadays, but stuff I'm doing. But I run also advocate diversity in tech, and I'm also the maker advocate for Dublin Maker. So like a quick rundown. The main bit is why did I make an on-air sign? Well, as you can see this evening, I'm actually hosting and streaming the PyLadies. So I've also part of my job with Dublin Maker, I also made a series, the first series of podcasts. So I've been doing a lot of online work, and I was joking around with Michael, my other half, who's saying that, why don't you make an on-air sign? So I thought I was going to 3D print something and put lights in it, and he said, no, there's another project out there. Why not? Why not use some of the components we have already sitting on the shelves and make an on-air sign? So the particular one that we're talking about is the Pi Moroni Ubercorn, which combined with the Pi Zero, I could actually make a kind of an on-air sign. You see, it doesn't. You'll see it now when you search for Ubercorn. First thing you come across, I come across all the time, is this BBC CBeebies Ubercorn. That's not what I'm talking about. I'm talking about the one with the LED panel with the multicolored lights. It's quite big. It's yay big. So that's when you do a search for Ubercorn. It's not the as lovely as it is, the Ubercorn, the CBeebies, is the other one I'm talking about. So it has 256 RGB LEDs in a 16x16 matrix. You can actually chain up these panels. Hold on, I might pin. So yeah, so there's like you can chain up these panels. So you can actually have a bunch of these Ubercorns to make a gigantic sign. But we only have one ourselves. It has Python library, so that's cool. There's more software than a hardware person, and you don't have to install all these kind of LEDs and stuff. It comes pre-assembled. That's pretty handy. So I'm gonna get a tiny bit out of the way. That is the link. If you go to Pi Moroni, do a search for Ubercorn, that you can actually find there. It's normally sold out, but quite popular. You might be able to get one. Again, as I said, it has a Python library. So it's the unicorn hash. So it has great instructions on setting it up, and it has a ton of examples. Run it and test. So, but I did come across a few things I needed to set up. After I pip installed it, I also realized that I needed NumPy and I needed font config. And then because I needed some of the fonts to appear when it scrolls across, so it just needed to load those fonts. So I think the instructions were in the README, inside the actual code itself. I also realized I need to install Pillow, which is which because I needed Pill, which is the Python imaging library. And then it came across a problem where it can't open this library, and go, oh, okay, what is it? So I did a bit of searching, and I found that I just need to install that. Then I tried to run it, trying to run Python imaging library again. It came across another issue, so I installed that as well, and that seemed to seems to be more of a Raspberry Pi Zero problem. So that, in the end, it works, which is great. I was able to, I think I ran a Rainbow Pi and it worked. I was really happy. So this was when it was working. So as you can see, you can just barely see it kind of scrolling across. Those are each of the LEDs with on air and do not disturb, just scrolling. So when I run this, this is actually with this project, I can actually have this outside the door connected up to a battery pack, and I can actually remotely connect to my Pi Zero to code running to turn it off again. So I decided to put a piece of paper over it because I think when I was following someone else's instructions, he uses this piece of paper so you can diffuse the light, so you can see it's a lot more visible, which is a lot cooler. So that was cool. So I was really happy with that. So the next thing was trying to put it in, because it was just a bare board. So there's a project where you can actually 3D print a game frame. So using an IKEA ribber frame, which is like gold dust. Couple of nights ago I was in IKEA. I think I got the second last one, because before that it was completely out. So if you have an IKEA ribber frame, use that. If you want to do this project, use that one, because it's really like gold. So this is the project I was following. It's the Ubercorn game frame. So you can see there is like a plastic grid that you 3D print out, that you put in front of the LEDs, and it kind of isolates these LEDs to make it shine brighter anyway and looks nice. And I put a piece of paper in front of it so it can light as well. And then pretty much like follow the instructions and what they had there, and 3D print it. You see it clearly in my next image. You can see that I kind of, well, I didn't 3D print it. It was actually Michael who 3D printed it. I just sent the instructions saying 3D print this for me while I try to get the rest of this stuff working. So, so credit to Michael for helping out in this project. There's a 3D printed kind of corner piece to hold up the Ubercorn as well as you can just see right at the front. I don't know if you can see it, you can just barely make it out just in front of the Ubercorn. There's a kind of a grid, a plastic grid. And then I had to measure to cut out all the bits at the back because the Pi zeros and things like that are popping out, and some of the Ubercorn stuff is kind of popping out the back. So I had to make sure that I measured twice and cut once, as Mike always says. I did that rather proudly because I did measure properly and cut, and everything fits. So I had to cut an extra notch out for the cable because I didn't. It was actually putting pressure on the cable. And then I had there was an extra piece, kind of a tester piece of the corner for the Ubercorn and for the IKEA frame. So I used that to kind of put it in the wee gap so the pressure of the board does not kind of fall on the Pi Zero, and I didn't want to put too much pressure on it. So that all worked. So as you can see, the light is on. So it's demo time. Let me. So I have this set up beside me over there. I have a camera set up with the book. First time trying it up. So I have a terminal. So this is on my Mac right now. So I have to SSH into Ubercorn. There's nothing much on this. By the way, it's really slow. When you flash it, when you basically you plug it in and you wait for it to boot up, it takes a long time. So setting it up took a long time, and so keep forgetting that it just doesn't instantly work when you turn it on. So there's not much stuff here. So stuff is looking. Yeah, there's just a bunch of demo, like all the example scripts that I got. Python library. So I used modify text. So watch I run this. It should work. There you go, on air, and it changes color. I control the out of it. So that is my demo on air project. We make a project, and all this is open source. So you can set the Python library first, and then for Unicorn I have for Unicorn, and the project to print out the game frame is also free. The guy actually has the 3D models and 3D print. So the only hardest thing to get is probably the IKEA frame. Put that first because it's like gold dust, or you can make your own frame if you do. And then the next one would be the rest. You should be able to buy a lot of. So that's me, and I think I just finished just in time for this to come on. So I won't have time for your questions. This I will anything else. Back to like number 2. Yes. Hey, Lais.
Hello. Sorry, I was mesmerized by your demo. I love this project so much. It's so cool.
So I am gonna pin you. So you are so.
Cool. Can we see my?
Yeah, I'm trying to pin you so I can actually just see you there.
If you want to pin the screen,
there you go.
Actually, yeah. Okay, cool. Oh, okay, so I'm sharing screen already. I don't know if you're able to see
the screen. Yeah, I can see.
Wonderful. Cool. Super cool. Thank you.
I'll let you know if things are too small. I'll give you.
Cool. Perfect. So you're going to be my proxy. You're going to be my eyes and ears. Thank you very much. Cool. So good evening, everyone. If everyone is in Ireland, I hope. It's a pleasure to be here talking to you tonight. So I have no slides. I'm going to be very bold tonight, and I'm going to do a little bit of a demo since this is a lightning talk, and it's just 10 minutes. So basically, I'm going to talk to you about how to convert your Jupyter Notebook to a framework that applies software engineering best practice to your data science and machine learning project. So basically, adoption of data pipelines. And the name of the library is Kedro. Well, it's basically a boilerplate based on cookie cutter data science. And we start from there. So I'm going to show you how to, I have a project like pre-arranged already. I will walk through each one of the folders with you real quick. Then I'll do the conversion for the Jupyter Notebook. This repo is on my GitHub as well. So if you would like to have a look later on, you're more than welcome to. And cool, so let's do this. Can you see? I guess you can see everything. Yes, cool, perfect. So the first thing you're gonna do is generate a new project with Kedro new. So pip install Kedro. It's gonna be, exactly, it's already installed for me. Then you're gonna generate a new project called with Kedro new. This new project, I'm gonna put test PyLadies because I won't use this project. I'm just showing you how to do it. So this is the name of your project. Then by default generates a repository name and then a Python package name as well. And if you type yes, then we already have a project like this on the repo. So I can do this one. So Kedro new, let's just call it test. It's the wonders of live coding. Cool. So generate the first boilerplate with code. Wonderful. So if you go over here, where is it that I can find this project? So test. This is the new project generated. It's the exact same thing that we have over there. So I won't mess around too much with this one, but we're gonna go into PyLadies demo. Cool. So as you can see, everything that is in here is in here. So generating this boilerplate, we have basic configuration. So in this configuration, we have our data catalog. There is basically a data connector to each and every single one of your data files, so your data sources. Then we have all the credentials in this YAML file as well, that kind of like by default, we just drop it in local because there is a git ignore file, so you don't end up committing your credentials, which is great practice. Then all the parameters for your project are going to be in this folder. Right here, I have already a parameter put in because this project was pre-made. Just be beautiful in this demo for you. So then here we have a data folder. This data folder follows the data engineering convention. And if you paid loads of attention to Nabanita's talk just a little bit earlier from now, you can see that these are the layers. These layers are necessarily the different steps for the blocks of building your machine learning project. So you have feature engineering, and then your model input, and then your other models, then your model output, and then your reporting by the end of it. And this is all the raw. This is all the raw data that goes into the project. So cool. So docs, basically Kedro uses Sphinx for docs out of the box. Then logs as well, it's done straight away out of the box. And then we have a notebooks folder. And then this notebooks folder is the folder where I actually wrote our initial Jupyter notebook. There's going to be the one converted. And then here the source folder is the one that has the meat of the project. So PyLadies demo is the name of our project here, the name of our initial folder, but it's also the name of our nodes and pipelines. So just for those that are not really sure what nodes and pipelines are, so nodes are pure Python functions. Basically, a node is a wrapper around a pure Python function. And then a collection of those nodes, it forms a pipeline if you assign dependencies and relationships between them. Cool. And then we have testers as well, and tests are done by default with PyTest. Cool. So let's have a look at this Jupyter notebook. So Kedra Jupyter notebook, and this is going to open our Jupyter notebooks for us. And then the fact that it's using the Kedra tag in there only means that you're going to be able to access the data from that is inside of your data catalog already. So cool. I hope you're able to see this. So we're going to start then installing pandas and matplotlib. It's already installed. Then we're going to import. So this is just to suppress a few warnings around, because I'm not really patient with warnings in the Jupyter notebook. I'm sorry. Then we're importing the library requests, the Python library requests. And then here we're determining a date and refetching the data. So the data that we're fetching, that we're using this project is from Singapore Weather API. And it's basically different stations and different readings for temperature for each minute of determined time series. So the date here, we're looking for data for the 10th of October for 2019. Then we are going to use this data into, so assign a variable responses, put this request in, and then parse everything into a JSON. Let's wait until this JSON comes back. Dun, dun, dun. It's taking a little bit of time because it's a lot of data. Cool. So here is the data. You can see it's loads of metadata. We have stations ID for those stations. And then we also have names and location for each one of them. And then if you keep scrolling, you can see here that we have timestamps for the readings for each one of the IDs. So station and then temperature reading. Cool. Then let's say we are interested on the temperature readings exclusively for one station. So what we're going to do here is we're going to get station S117, and we're going to look through items and timestamps, and we're going to put all those temperature readings and the station ID from each station ID into a list. There's going to be the output. Now, the reason why this is producing an error is because I need to fix this font over here. So it's using the data from cell number 6. So we do this here and run it. And then if you run again, we get cool. So we get a bunch of readings for that date. Cool. And then I want to show you a plot for the temperature readings. Cool. Then what we're going to do is we're going to convert this into the Kedro project. So I have a few instructions here for you if you'd like to have a look at this notebook later on GitHub. But basically what we're going to do is, sorry about this. So we're going to go into view, cell bar, and tags. And then here we're going to add node on this one and node on this one. And cool. Then we have here station ID 117. No problem. We're going to save this. So it's checkpoint saved. We're going to go back here. I can actually stop this notebook. I'm going to go with brute force. And then we're going to go, so Kedro, Jupyter, convert all. Ooh, typo. Wonderful. So here we have then, it converted everything into the notebooks, start, Aperture notebook, done. So our nodes should be in here then. You can note that this is the same name as the notebook. This is the new file. I don't need this right now. So as you can see, so it's all converted. I was always wondering why Pandas doesn't want to come. Cool. So everything is here. Then we're going to need to do a few adjustments. So basically, you need to import your two functions from there. And I've already done that. It's here. I'm not really following why Kedra doesn't want to, it's not installed just yet, but we get there. And then the other thing you need to do is to go here in base and to put your data connectors into this file. And then you need to elect your station, put your station here. And then by the end of it, we need to put together our data pipeline. So basically, you're gonna have one big data pipeline that's gonna take 3 nodes. So the first node is gonna use the get temperature data. It's going to take no inputs, and it's going to output raw temperature. You can see that it's going to output raw temperature. And then you're like, well, where is it going to output it to? It's going to go into the raw folder with a JSON file. Then the choose station function is going to take as input the raw temperature. There is the output of get temperature. And also the parameter on the parameters.imo, that is going to be the station ID. And then it's going to transform the data, and it's going to output temperature. And then finally, our third node, it's going to take, it's not going to transform the data, but it's instead going to generate a graph. So it's going to take as input the temperature, and it's going to output the temperature plot. And this here is just because we're using matplotlib. Cool. So I'm not sure if everything is installed. It doesn't look like. I don't know what's going on. But we can try and run it just for the sake of it. Okay, so typing Kedra run should make everything start. So, okay, so it's grabbing the raw temperature output. It's running the first node. So let's see. Now it's time of the truth. Woo! Everything run. Great. So basically, we have it ran the first node here. So this is the output of the first node. And then it loaded the output of the first node, the JSON data set. And then it grabbed the station parameter ID that you can see it's the other parameter in this. And then it went into and fed into the choose station function. And outputted the temperature, as it's saying here. So that was the completion of the second node. And then for the third node, it did the same. So the way that we can see if this worked or not, we can just go into our data, and we can see here on the data 1 raw, we have a JSON file here that luckily I'm going to be able to show you. Yes, with all the ID devices and with everything that came back from that request. And then here on reporting, we have our graph. Beautifully done. And then let's see, I will try and show you the version of this that is a DAG. Cool. So it worked. So here we go. So Kedro also has this plugin called KedroVis. And basically what KedroVis does is show you a drawing of how your functions are working. So here you can see we have the function get temperature data that fetches the data from remotely with the URL. It outputs raw temperature data into a database. There is actually a JSON file. Then it goes as input to choose station with the station ID. Then this function, after transformed, outputs a temperature, and then it goes as input to the lambda function and outputs a temperature plot. And that's it. I am done. And that's how you convert your Jupyter notebooks to a framework to make them into data pipelines. That's it. Thank you. Did I explode my time? A little bit.
It's okay. Thank you so much for that talk. I don't think we have some time for questions, but I think it's time for a raffle. So thanks again to all our speakers this evening. You know, Lais, you'll be running off because you're giving another talk this evening. But I just want to do a shout out. There's going to be there's a question on the live stream. You can answer it there as well, and I'll post it to people afterwards. But for the raffle, we're going to do a raffle now. There's going to be 3 copies of Machine Learning book camp by Alexei Grigorev. I think it's his name. So for anyone who wants to participate, I'm going to give you like probably next 20-30 seconds to say me. We'll enter your names into our name picker, and I'm going to get the list from Lais, and I'll copy it into a name picker, and we can pick out the names live, and folks can contact me afterwards and tell you how to claim those books. I suppose 30 seconds. Or answer questions. Everyone wants a book. Wow, okay, that's a lot of names. I thought I removed your pin. Nope, you're not pinned. I think you are just on the speaker view. There you go. Bunch of us there, all of us speakers, Lais and Michael. Okay. I'm going to say, Lais, are we good with the names? I think we'll do a cutoff now. I didn't keep a timer.
Let me count. One.
Names. I know we have multiple. I
have 13
names. Great. Let me see if I can. Oh yes. For people who are curious, I am using something called namepickerninja.com. You load it up. I tend to use this a lot. Bit of a cutoff because I had it for the ad, so this. Oh, very JavaScript. I'll grab names. Thanks, Lais. I'm gonna pick 3 names. See if I can copy now. Oh no, I can't copy from Zoom chat. If I remember this. How to Oh, technical difficulty number 1. I think we had this problem before. How to copy text from a Zoom chat, because you can't copy from Zoom chat. WhatsApp. That will do. Ah, yes. Hey, Lais, if you're gonna do a raffle, this is what happens forever. If you're gonna, Lais, if you do something similar. Get my WhatsApp. Yeah, just hold on, people. Bear with us for like another few seconds. Getting names. And folks can answer questions on chat while we're waiting. Ask away on chat. Thank you. Yes. Ta-da! These are all the names. So I'm gonna pick 3 names. It removes a name every time you pick it. Hey, congrats, Joan. So just email me, drop me an email at dublin@PyLadies.com. Let me take down your name as well. I know this is all recorded, but I'll take it down on a piece of paper. Well, too late now. It's already in there. I'm not. Too late now. Okay, remove name from list, and we'll see who's the second winner. Right, Joan. Elena Nicola. Congrats, you are the second winner this evening. Drop an email to dublin@PyLadies.com, and I'll send you information on how to claim. Now the last book. Let's see. Ayinkia Sakara. Congratulations. Same as before. What I said before. Just drop an email to dublin@PyLadies.com, and I'll send you information on how to claim the book. Let me write down your name. Technology. I'm still using paper. And that is it, everyone. Huge thank you to all our speakers. Huge thank you to Lay and Michael. Lay especially for helping with the names and the chat and stuff like that. But yeah, to Nabanita and Lais, thank you for speaking this evening. Thank you everyone who has joined us this evening. It's really appreciate all your support. Because as you can see, I'm freaking out every time I do a live stream. I'm just gonna push this up to say when our next PyLadies again next month, Tuesday, November 17th. We've got 2 talks, 2 very different talks as well. And then another raffle. Hopefully it'll go swimmingly again. So yeah, I'm just seeing there. All right, people just chattering away on live chat. So I will say we're run a bit over, and I will say good evening to everyone and thank you, and stay safe until I see you all again next month. Bye.